All right, so this question says that we've got a hydraulic system. A small piston with this area is used to lift a car with a mass of this using a large piston with an area of this. What force must be applied to the small piston to lift the car? And so this is another F1 over A1 problem. Is equal to F2 over A2, right? And so I know that this is what we're dealing with because we're dealing with a hydraulic system. And then from that, I'm going to figure out what numbers I need to figure out. So F1 is really the number that I want, right? F1 is the number that's applied to the small piston over the area of the small piston, which is 0.015. That's going to be equal to, and what is F2? What is the force we want to apply to the large piston? Well, the answer is that we want to be able to apply the force counteracting the force of the car, right? The car is heavy and it applies a force on the piston due to gravity, right? And so F is equal to mg. Force is equal to mass times the gravitational constant. And so in this case, I'm going to go ahead and round this number to 10, and that's going to be 15,000. So 15,000 newtons. And so that's the force that we need to apply to the large piston, or that the large piston needs to apply in order to lift the car, right? If it were too low, it's not going to lift the car. And so this divided by the area of the large piston, which is 0.45. And so this is a case where the math is potentially very, very ugly. And so I'm going to go ahead and show you a shortcut, a way that I would do this such that the math is not so ugly anymore. And that is by replacing these two numbers with dummy numbers. And I'll show you what I mean. So since these are on opposite sides of the equation, it doesn't actually matter what the numbers are. All that matters is what they are relative to one another. So 0.45 divided by 0.015, right? That is 45 divided by 15, that's 3, right? And then there's an extra 0, so it's 30. Right? That is to say that 0.015 goes into 45 30 times. And you can check your math by multiplying 0.015 times 30, and you get 0.045, and then you add that 0, so it's 0.45. And so the relationship between these is, or the ratio between these is the same as the ratio between 1 and 30. So I'm going to replace these numbers with 1 and 30. And I hope it's clear how or why I did that. I did it specifically because the math is ugly, but also by noticing that 0.45 and 0.015 are actually pretty neatly divisible by one another. And so again, 0.015 times 30 is just 0.45, and so I was able to replace them. And so now the math is fairly easy, I think. F1 is equal to 15,000 divided by 30. What's 15,000 divided by 30? That's 15 divided by 3, that's 5. And then let's see how many zeros we're dealing with. So 15 divided by 3, and then we have 2 zeros on the top, so 500. So we got 500 newtons. And I think this problem was a little bit difficult mathematically, but hopefully not difficult conceptually. So I hope that you were able to at least set up the Pascal's law over here without the 1 and 30, even if the math itself might have sort of defeated you. It might have been too difficult. But I hope you at least got this far. And as long as you got that far, then conceptually you understand the concept. And I think the MCAT typically will not do this type of math to you. I think that this type of math is a little bit annoying, but I would still recommend you practice just in case. But maybe it's not the highest priority. Again, the highest priority is to understand how to set this equation up in the first place. And so otherwise, the force that has to be applied to the small piston is 500 newtons. So the correct answer here is C.